is Eylene Pirez, and I'm an astrophysicist, and this is the orbital speed of Neptune. So first let's go over the equations and the data that we need to find out the orbital speed of Neptune. Orbital speed is equal to the square root of the gravitational constant times the central mass, which in this case is the Sun, and I will denote it with a circle and a dot in the center, divided by the distance between Neptune and the Sun. So we need to know what g is equal to, the mass of the Sun, and we need to know the distance. Now, g is equal to 6.67 times 10 to the minus 11 meter cubed per kilogram times second square. Now, what's the mass of the Sun? The mass of the Sun is 2 times 10 times to the 30th kilograms. And then the distance between the Neptune and the Sun is about 30.1 astronomical units. And for simplicity, I will give it to you in meters just so our units can match. And this is about 45 times 10 to the 11 meters. I will keep it like 45 to demonstrate a quick math example. So if we put this all together, we know that the velocity is equal to, let's round this up to 7. So 7 times 10 to the 11 to the minus 11 times 2 times 10 to the 30th divided by 45 times 10 to the 11th. So what can we do this to simplify this and not having to pull out our calculator? Well, 7 times 2 is 14. We can round that up to 15. And 15 divided by 45 is 1/3. So then our square root is 1/3. Now let's figure out the scientific notation. 10 times 10 to the 30th is going to be divided by 10 to the 22nd. So what is this? This is 3 times 10 to the 7th. 10 is in the square root, and it's going to be meters square per second square. Now, when we take the square root of this, it's about 5,477. But now we have this in meters per second. Generally, you want to have an idea of what it is in kilometers per hour. So in order to do this, all we have to do is multiply it by the amount of seconds in an hour and divide it by how many meters in a kilometer. And the conversion factor for this is 3,600 divided by 1,000. And what this will give us is 19,717 kilometers an hour. Now, we did a lot of rounding up and we got to this number. The actual accepted value is 19,720, which we were off by 3. This is to demonstrate that when you're working with numbers that are small as 10 to the minus 11 or numbers that are as big as 10 to the 30th, you are free to round up and you don't need an actual calculator to calculate the speeds. My name is Eylene Pirez, and this is What is the Orbital Speed of Neptune?